Hey, Mari.
Gotta close this out. The monitor's on. I can hear you.
Nope. Not something muted. I got the sound of
You
wheel.
gotta close that out just to be on the safe side.
I will in a minute.
Because the monitor's on.
I understand that.
Thousand years into the past. This is possible by measuring carbon-14 ratios. Carbon-14 is a rare isotope that is generated when cosmic rays, which primarily originate at the Sun.
Check.
Nice to be here. And
right.
thank you for all the work you and Mari have been doing. It's great to see your focus on the next grand solar minimum. I wish there were more people like you and Mari helping get the message out.
It's growing. All right, so happy Memorial Day weekend to everybody out there. We thought we'd come on and do a live stream. It's been a while since we've played some videos back to back like this in a while. So while you're waiting for those ribs to cook on the grill, or maybe you're getting dinner ready for today, go ahead and put this on, turn it up, and maybe A few of you haven't seen some of these videos. Some of you are new. Some of you have seen these before. But these are a collection of the best of grand solar minimum as far as getting the most out of education that you can. And we put together a playlist. Actually, Mari put together this playlist, and we've been using it several times. But we haven't done it in a while, so we hope everyone's having a safe weekend and enjoy the playlist. All right, everybody, welcome to the Grand Solar Minimum channel. Today, we have a very, very special guest with us. Retired NASA and NOAA scientist, author of the book Cold Sun, Dark Winter, and his latest that was released this last December, Upheaval. John, how you doing tonight?
Doing just fine, Jake. Thanks for having me on.
John, this has been a long time coming. We were reached out to you weeks ago. We are very excited to have you on our channel. I mentioned in our communication that we consider your work as a foundation and beyond for our channel. We're thrilled to have you here, and it's an honor. Thanks again for being here.
Glad to be here. And thank you for all the work you and Mari have been doing. It's great to see your focus on the next grand solar minimum. I wish there were more people like you and Mari helping get the message out.
It's growing. I can tell you that. The results right now are tremendous. There are more people engaging in our community about this than there was, say, 4 weeks ago. So, yes, that's our main goal here at this channel. We want to work with everybody that's on this topic. Okay, so I'd like to ask a few questions here, John. And I know you've probably been asked these quite a bit. The first one I wanted to ask you was, when will it be obvious that a new cold epoch has arrived as predicted in your book, Dark Winter?
Well, actually, it's already obvious to a lot of people on the planet. Regrettably, the media still does not tell what's happening to the extent that they're still pushing the man-made global warming story. But if you were in Great Britain in February, you would already know that the next cold epoch has begun, because all of a sudden you've been told that cold weather has killed much of the vegetable crop and you can't get lettuce or cucumbers in your grocery store. And in fact, there are actually people fighting over vegetables in Great Britain grocery stores in February because of the cold weather Europe was getting. So over there, a lot of people may feel that it's already started to hit. On the other side of the planet, the capital of Australia, Canberra, where my director of research for our earthquake research company is, said they just set new cold weather records down in Australia. So it depends on where you live, but certainly here in the US, we're still dominated by the media and the government, or at least the previous government, telling us something about the climate that's probably not accurate. More specifically, to know that the next cold epoch has hit with certainty will come, in fact, when we have that first bitter cold winter that lasts until spring and destroys our food supply to a large percentage. We did have losses this spring, but the media hasn't discussed much of that. So the short answer is when things start to disappear in the grocery store and the supermarket because of cold weather damage, then probably people will stand up and say, what's going on? I thought everything was supposed to be getting warmer, not colder.
Yeah, and you mentioned the media not communicating. We've done several updates that we have little 2-3 minute clips that we show, and a lot of the stuff that we report on is not in the mainstream media. You really have to dig to find some of these freak hailstorms. You talk about South Australia setting cold records. I got an email from a gentleman who lives in New Zealand right now, and I guess they hit minus 11 degrees Fahrenheit, and that's pretty cold for them at this point in their winter. They think their winter's 5 to 6 weeks earlier than what it's supposed to. So there is evidence of what you just said here all over.
Your comment about New Zealand, one of the big myths that we keep hearing about is the fact that glaciers all over the planet are shrinking and will disappear. New Zealand's, I think, got 26 major glaciers, and they're all growing at the fastest rate they've recorded in the modern satellite era. So again, who knows about that here in the U.S.? No one, because the mainstream media won't discuss it.
Right, exactly. All right, another question I had for you as well. What is the current status of the Earth's temperature, and can we trust what the government is telling us?
The current status is that we've just come off a peak of warming in the 2015-2016 period. But as I predicted in early 2016, this would be the last such warm spike in global temperatures that we will have probably for the next 400 years. Since early 2016, global temperatures have continued to drop. We had another very steep drop in June, from May to June. I believe in May we had an anomaly of 0.43, and it went to 0.26, so a big drop from May to June. And I expect this drop in temperatures to continue and to be essentially unabated until we get to the 2040s. So we'll certainly see ups and downs. Weather and climate do overlap on a yearly basis and every 2 years. So you will see variations, ups and downs that are quite rapid and large. But we're on the downside of the 206-year solar cycle. There's nothing mankind can do about it. We'll just have to recognize that global temperatures are going to continue to drop. So that's the current status. Right now, we are, if you look at a straight line graph, there's been effectively little to no change in global temperature for 20 years now. Prediction was made in April. I posted that online. The prediction said two things. It said global temperatures would drop over the next year, which they have done exactly as I predicted. But I also said that the spike in temperatures, which was produced by a spike in solar heating, nothing else but solar heating, was probably going to be the warmest that the human species, our peoples, will see for probably 400 years. The reason for the 400 years is the 206-year cycle. We're now going up and we're peaking and we're heading down rapidly. And when we come out of this and then head back up and start warming up, it'll be in the 2040s. But even after that, we won't get very warm. So it'll be at least two cycles of 206 years, so 412 years before we see any significant warming again. And quite frankly, that far out, you see other major solar cycles at play, and the analysis isn't done on those. Some people are looking at those cycles, but it could be that even after 400 years, it'll only get much colder.
Some are predicting a Maunder class minimum. What are your thoughts? Also, what is the time frame to reach that point? And could you expand on the last Maunder minimum and how that affected civilization?
Right. The first part of your question is how soon and will we get down to a Maunder class solar minimum? There are many who believe we are heading into a new little ice age, which in terms of the Maunder minimum refers to the period of time when the sun had dropped in intensity and was the coldest period of the so-called little ice age. That was 1615 to 1745 specifically. That's the Maunder minimum. And that was a period of time when New York Harbor froze over and stayed froze over. The Thames River stayed froze over. The Baltic Sea stayed frozen over. Countries, people could go from country to country across the frozen Baltic Sea. And it was so cold and the ice was so thick that they actually built hotels and shops and other facilities out on the ice for travelers that were going back and forth between countries over the frozen Baltic Sea. That's how bitterly cold it was. And of course, during this period of time, we had some of the world's greatest warfare or battles going on. Starvation was common, famine and plague were common, illness was everywhere, life expectancy dropped dramatically. There are a number of very good books written on this period of time, and I recommend anyone that wants to do so just research the Maunder minimum and that period of history, especially European history, and you'll see how difficult life was, how crops routinely failed, people starved to death. It was not a good time to be alive. And unfortunately, our Russian colleagues are totally convinced that we are heading into a little ice age again, like we were in the Maunder minimum from 1615 to 1745. My own research says we are not heading that deep, but it'll be bad enough. We believe we'll be seeing not a Maunder minimum, but a Dalton minimum, which lasted from 1793 to 1830. That was pretty bad. That was pretty cold. Rampant warfare existed throughout Europe during that period of time. The War of 1812 struck here in the U.S. So there was lots of warfare, lots of famine, lots of death and destruction from the collateral effects of war. But also, you had this bitter cold that had descended on the planet. Not as cold as the Maunder minimum, certainly bad enough to destroy crops. And lest we forget, in 1816, here in the United States, the so-called year without a summer, we literally had no summer in the New England states.
Wow.
We had snow and freezing rain in the dead of summer in August in 1816.
You know, and I've reached out to local meteorologists back home from where I'm from in Southwest Ohio. And, you know, we go back to talking about how the media doesn't really talk about what's happening. And I wanted to pick his brain about what he thought was the, you know, what was going to happen with this next upcoming minimum. And this is the same answer that I've gotten from most mainstream media, is that there's, you know, the CO2 is going to, you know, overturn this whole thing. And that leads me to my next question. What is the truth about CO2 and its impact on the climate change?
Well, of course, that's been the grand theory. It is a grand myth, in my opinion, and that of many other researchers, that CO2 is the primary driver of climate change on Earth. There's simply no serious science that supports that contention. What we do have coming out of the United Nations, however, are lots of bogus myths and bogus science. The ClimateGate scandal showed very clearly that the scientists at the United Nations Intergovernmental Panel on Climate Change were falsifying the data, were hiding the data that showed the planet was actually cooling in a number of years. And we also have coming out of that group, echoed during the Obama years, many models of climate that were developed costing billions of dollars. And what we now know is those models were in error by 200, 300 or more %.
Goodness.
These models are absolutely worthless from a scientific standpoint. Unfortunately, again, the mainstream media uses the output of these very poorly constructed models and the extreme predictions for sea level rise and global temperature rise by the year 2100 as the basis for political action and social action here in our country. It's very sad that bad science has taken over in the media and during the Obama years in our own government.
Yeah, I don't understand what the sense of not exploring this and making it a topic of awareness throughout since I've been researching the grand solar minimum with solar sunspots, how CO2 does not drive our climate. So it's
Well, I didn't answer your question, and I apologize. But aside from the models in the UN climate reports that are all based on mankind's CO2, he probably is aware of this, that CO2 is actually a trace gas that is such a very small component of the atmosphere that it has very little to do with climate. Uh, does mankind contribute to CO2? Yes. Does it have any kind of warming effect? Yes. But in the grand scheme of things, it is a very, very small component of global temperature. Clearly, the sun is overwhelmingly the central source and the most powerful force in the solar system for driving the temperature here on Earth. CO2 produced by mankind is at best only 5% of naturally produced CO2.
right.
So again, all the numbers show that CO2 cannot be the primary driver, that the falsified, manipulated reports out of the UN have been showing for more than 3 decades now. Very sadly, it's all bad science.
Yes, agreed. Recently, we saw a ice shelf break off at Larsen C, and it leads me into this next question.
Yes.
What is the status of sea level rise, and how bad is the threat?
Sea level rise is continuing, although the rate is slowing down. That's a very key statement. The man-made global warming community says as long as CO2 goes up, then sea levels will go up lockstep. There's some relationship, but again, a very small relationship. Sea levels rise and fall for a number of reasons. The primary reason is the heating of the oceans, which causes them to expand. Our globe, as you can see behind me, primarily 71% water. And as that water heats up, it expands. So as long as the sun has been heating up for the past 200 years now, we have seen a gradually expanding, rising sea level. However, Dr. Niels Axel Morner and a number of other experts on sea level and myself know very well that there's a cyclical pattern to sea level rise. And it occurs pretty much on the same cycles as the sun. As the sun warms the planet, sea level rises go up. And as the sun starts to cool and that cycle drops, then of course we'll start seeing sea levels drop as well. We had a very important news conference, August the 21st, I believe, 2014 in Miami. I don't know if you heard about it. We indicated very clearly that sea level rise is a function of the sun and the heating of the oceans, and that beginning no later than 2020, we would see the rising sea levels start to abate. By some measurements, that's already begun. We indicated in that press conference that between 2014 and 2020, we would see the changes in sea levels start to manifest themselves. There's also a big question about sea level rise, even though, again, these fabricated, these falsified data sets that are being used by very poorly constructed climate models at the UN say that we're just going to see more and more sea level rise between now and 2100. History and actual measurements show that's not the case at all. Whereas Al Gore is telling the world that Florida will be flooded with 21 feet more of sea level rise between now and 2100. The reality is, if you use the gold standard for measuring sea level, that there's going to be very little sea level rise between now and 2100, even with the current rate of growth of CO2. There's a big disparity right now between the satellite measurements and the actual tidal gauges, which are the gold standard for measuring sea level. And these tidal gauges are all over the planet. The satellite measurements show a rapid growth in sea level rise, but the gold standard says, no, we're not seeing it at all. Instead of 3.2 millimeters per year, which the UN says we're seeing, The reality is it's closer to 1.2 or even less per year. That says that there's no big concern whatsoever for future sea level rise, even with the current rate of warming. However, now that the sun has maxed out and is on its way down, the oceans will start to cool. And I believe in the 2030s and 2040s, we'll be right back to where we were during the Dalton minimum, where sea levels dropping dramatically 20 to 25 centimeters uh, over the next 15 to 20 years, getting us back to where we were in the year 1800 at the bottom of the Dalton minimum. So that's what we said in our news conference. But again, the CO2, the global warming crowd, Al Gore and company, all they're doing is talking about bad science, bad models, and scary predictions that aren't going to happen.
Yeah, you mentioned bad science, and the next question I had for you as well. I heard rumors last year that we would be an all-water event, that the caps, everything would be melted by 2017. Are the Arctic, Greenland, and Antarctic actually melting?
The Antarctic and the Arctic, just like all other natural phenomena, go through cycles. Right now, and for the last 2 years, the Arctic has been dropping in temperature, Arctic sea heights has been growing, and that's been the case with the Antarctic. Bear in mind that the Arctic and the Antarctic did see a large spike in melting during the same time we had that spike in solar heating. That's exactly what we should have seen. And for those who looked at the documentary that was done on my book, Dark Winter, I actually showed in that video, which was produced in late 2014 and early 2015, that the sun was going to produce a spike in activity. And it happened exactly when I said it would. So again, natural cycles are at play. We did see a lot of melting in the Arctic and the Antarctic. That's now turning back around. And if you look at the long-term picture in the Antarctic, there's been very little warming whatsoever for over 100 years now.
Yeah.
And in general, the Antarctic continues on a very slight cooling trend and has for decades. The Arctic is a little different. It's more subject to northern hemisphere weather patterns and the polar vortex, which is nothing more than a counterclockwise rotation of winds. The Arctic is not at all a monolithic entity like the media would like you to believe. For example, some areas of the Arctic have 1 meter of ice thickness, but other areas have 5 meters or 15 meters of ice thickness. So it's a very different non-uniform area to study. So again, going back to the science, it's very different than what the media is telling you.
Yeah.
Right now, both Antarctic and the Arctic are in a cooling trend, which is about 2 years long right now.
My favorite headline so far this year about the Arctic was the group of researchers who are going to study the effects of global warming, and they get their ship stuck in ice and had to abandon the entire research project. So that right there should have been the first red flag that folks like yourself, this is a serious topic that should be raised, awareness should be raised as well. And I saw something a couple days ago that really blew my mind. Megyn Kelly had asked Vladimir Putin about Trump's recent decision of pulling out of the Paris Treaty, and the look on his face was his eyebrows raised, and he looked at her as if to say, "Are you serious? Record snow in Russia, and it's cold and rainy right now." And that's all he had to say. His feeling about it was like, "Are you serious?" Basically, Trump did the right thing. And I guess where I'm going with this is, why are so many other global leaders not following President Trump's lead on getting out of the Paris Climate Accord that happened in December of 2015?
Several good reasons for why they aren't. First off, it's important to understand that even the Kyoto Protocol of the 90s was bought off by many European leaders, and they began to implement CO2 controls on their industry, and they got into carbon credit trading very early. Uh, Europe, generally a socialist union with the European Union, adopted very quickly any UN report that came out and recommendations from those UN reports. And so they are way ahead of the US, China, India, and other countries in implementing the UN Accords. Many of the people that worked on those science committees, the leading science institutions were in Great Britain, a member of the European Union. Much of this got started in Great Britain during the Margaret Thatcher years, and many of the people that end up in the United Nations Environmental Development Organization came out of the UK, and then Germany and France and so forth did their part. So they were well ahead of us and still are implementing Kyoto protocols and picking up what they said they would do in the December 2016 um, Paris Accord. I'm sorry, 2015 Paris Accord. So uh, they are vested now. That's the big issue. The U.S. was never fully vested. California, of course, is fully vested in the Paris Accords, but the U.S. government is not. Thank goodness for the conservatives in our government who fought this. Uh, but the Europeans, their businesses, their banking, their environmental organizations, they're all on the same sheet of music. Um, so it's going to be very difficult for them to change. It's going to take a long time for them to change and go back to the reality of good empirical science instead of political science as their motivations. Let me go to a specific issue, which
Okay.
is the one of carbon tax. The carbon credit and carbon tax structure is already going forward in Europe, and to many government entities in the European Union, their debt structure, their lackluster growth in economy makes it very difficult for them to impose taxes. With this CO2 myth, they've been able to convince many of their people to approve these carbon credit and carbon taxation structures. Um, so now they are wedded to that income stream in their governments. That makes it even more difficult for them to change. Fortunately, we never implemented a carbon credit here. Fortunately, back in 2008 and 2009, the Chicago carbon credit exchange collapsed after word got out that the earth was cooling, not warming. Uh, so uh, that all shifted to Europe, and that's where it still resides. Fortunately, the U.S. never bought in to the Kyoto protocols and especially the 2015 Paris Climate Agreement.
Just curious, do you know how much that would have cost American taxpayers if we had gone through and stayed in this accord?
Yes, there have been a number of estimates. The ultimate estimate is something like $1.4 trillion over a 10-year period would be the cost to the American consumer and taxpayer to implement the Paris Climate Accords. Obviously, our economy is still anemic at
Sure.
best. We are not seeing the kind of growth we should. We're now a country that's heavily burdened with debt. And so for us to pick up another $1.4 trillion in debt by imposing climate restrictions, that would certainly be onerous, if not deadly, to our economy.
Uh,
Bear in mind something very important here. Regardless what the Europeans do in implementing the Paris Accords, if every country implemented the Paris Accords as they agreed to do, it would have very little impact on the climate whatsoever.
it's a shame that it took an administration change for this to happen, for our government to pull us out of this treaty. I think our current government saved this country a bunch of money by doing it's the right thing, and more evidence has been coming out since 2016 of, like you mentioned earlier, they're fudging numbers. The data is just simply being cherry picked. And I've had, you know, since we started this channel, we get people that ask us questions, and they cherry pick from the data. They don't want
Right.
to they don't want to reveal the entire picture of everything, and that's why we do
Right.
a show called The Big Picture, because we want everyone to see the entire, all the ingredients, not just one factor. So
And that's what I like about what you're trying to do. The title that you have, the Grand Solar Minimum, your website says it all. The Grand Solar Minimum is based on cycles that are 100, 200 or more years long. And for the mainstream media, they pretty much have to ignore these grand solar cycles and grand solar minimums and focus on very narrow periods of time when the Earth is warming, and from that extrapolate up and say, well, this is the way it's going to be for the next 100 years, when in fact we know that it's up and down in
yes,
a general trend and never a straight line cold or a straight line warm.
no,
So yes, the mainstream media and the global warming movement have intentionally cherry-picked the data that they like and ignored the vast amount of data that says climate is driven primarily by the sun.
When we talk about how the TSI does change during the maximum and the minimum, and they talk about the average is 0.1% variance during this minimum, how far down in TSI do you think we'll go? Where do you think we'll bottom out? What are your predictions for sunspots through cycle 25, 26, 27?
I'm really pleased that you asked about TSI because it's total solar irradiance, something all of your listeners need to be aware of. Total solar irradiance is the amount of radiant energy that's delivered on the upper atmosphere of the Earth. And as that varies, so varies the climate on the planet. If we are getting too much solar irradiance, we get hot temperatures, we get high sea levels. If we don't get the right amount of TSI, then the Earth gets colder and sea levels drop. And basically, that's one of the key measurements of which direction our climate is going, is following that TSI, the total solar irradiance. A couple big things to understand about it. Number one, you're right. Between the 11-year solar cycles that we learned about in high school, every 11 years, the sun grows in intensity and energy output, and then it drops off, and then it picks back up again. And at the peak of these 11-year cycles, the sun's magnetic field reverses. So these are things we learned in high school. At the bottom of these troughs, where the sun's activity is lowest, we do see a big drop in the TSI. But this really doesn't affect climate unless you have multiple 11-year cycles showing much lower than normal energy radiation from the sun. Then we have a climate change. And that's what we're looking at in the next cold climate epoch, the Eddy minimum, it's called, named after Dr. Jack Eddy, who passed away a couple of years ago, unfortunately. Great scientist, but the next cold or grand solar minimum, named for him, we believe will last for at least 22, maybe 33 years. That's 2 or 3 of these 11-year solar cycles. And during that period of time, the Earth will get very cold. Well, that's number 2. Number 1 was the fact that even though we have the dips, they don't amount to much climate variation. But when you combine them, number 2, then you get that. That's also reflected in the sunspot count. When you see sunspot counts that average only 50 sunspots on average at the peak of these 11-year cycles, and you get 2 of those that are 50 sunspots or less, then you're down into the Dalton class of minimum, and that's where we think we'll be through the next 20 to 30 years. The other thing to bear in mind, a third point actually about TSI, is how we measure it. even though it's measured by satellites typically at the upper atmosphere of the planet, there's a lot of variation there. And the variation comes from the fact that we've used different satellites, 8 or 9 different satellites in the last, since 1979, to measure this solar irradiance, this TSI. Right now, the source satellite is the #1 satellite that we're using, and it's running about 1,361 watts per meter squared. That's about, well, again, this 1 meter square on the surface of the upper atmosphere, and we see about 1,361 watts. In the previous satellites, though, we saw 1,366 watts. Now that's important to note. We can now combine the two groups of satellites, the ones that were at 1366 and the new source satellite at 1361, and we come up with a composite. Bottom line is, what we now know from the TSI studies over the last 30 years is the very slightest change in that TSI reading can mean the difference between the modern warm period that we're in and a little ice age like we had in the Dalton minimum, I'm sorry, the Maunder minimum, 1615 to 1745. In fact, you're probably familiar with the phrase that the Earth is revolving around the sun in what's called a Goldilocks zone, not too hot, not too cold. Actually, we live on a knife's edge in that Goldilocks zone around the sun. What I mean by that is the very smallest change can bring on an ice age. Instead of an average of 1361, if we were at 1360 and stayed that way for 20 years, we would be in the Maunder minimum. That's an unbelievable statement, but that's what history has shown us, that 1 in 1,361 parts is all that we need to see in a change in the sun's intensity to give us a new little ice age.
Well,
We think it'll be less than that coming up. Hopefully, it won't be as bad as the little ice age and the Maunder minimum, but it's still going to be very cold, dangerously cold for our agriculture industry worldwide. But I'm so glad you brought up this matter of TSI. Thank you.
I wanted to add real quick to the TSI. I'm glad you mentioned the two different readings. And I've been following the source website myself, and I've noticed just looking back, it goes all the way back, I do believe, to '04, maybe '07. I'm not sure when they started. But since October, we have been sitting at somewhere between 1360.9 and lower than that. Nothing below 1360. But I noticed the two difference that if you go to the NASA website, they'll show 1365. Then if you go to source, they'll show a different number at 1360. So I'm glad you touched base on both readings. They do come into a factor at some point.
You can use either standard. If you use the 1366 standard of the other 8 or 9 satellites, their aggregate average, then you have to drop 3 parts of that lower down to 1363 to get down to the Maunder minimum. But if you use the standard of the source satellite at 1361, you only need to drop 1 watt per meter squared to get down to the Maunder minimum. You can use either standard as long as you know which one you're using.
Gotcha.
Of course, it's a great satellite. It's got 4 different measurement instruments. I hope we continue to use the combined data from the other satellites and the source. The problem we have with a single-use satellite like the source is the fact that there may be changes in the physics of the instruments that are measuring the TSI. And for example, we've had other satellites whose platinum resistors that were used to measure temperature had gone out of range of, there's an operating range that they exist in, and their data went out of the range, which indicated a failure of a component. That's the problem when you rely on one satellite and one instrument, because you obviously want to get continuous averaged data and not rely on one data set and one satellite.
One of the things I'd like to talk about when we were talking about that fluctuation of TSI, when you were doing your research, as I understand, you have researched Eddie's research.
Yes.
There were places around 2009, I believe it was, where there was a variation over 2 weeks of 0.34%. There was a drop where there was a sunspot going across the base of the sun. Are you familiar with that incident?
Yes. And there are others. For example, when Mercury and Venus transit across the disk of the sun, they also produce a very significant drop in TSI here on Earth.
Thank you, John. So as we get increased coronal holes, if you want to talk about the history of coronal holes and how they are growing, I would like your opinion on how those coronal holes, because as we know, that's a cooler area on the sun. If we keep getting these large coronal holes and increased particles, they're coming in and they're increasing cloud nucleation. That nucleation is creating additional refraction back into space. That refraction in space is dropping the TSI that we're getting here on the planet, which leads me to believe that the increased amount of galactic cosmic rays, you're following that data too, right? Okay, so we're, say 16% in the middle, the north part of the country, and 19% in the northeast in galactic cosmic rays over the last 10 years. So if that continues to escalate like that, then you take the data from Dr. Kirkby from CERN. Are you following the cloud project there?
Yes.
Okay, so if you take Kirkby's original work and you put that together and you add all the aerosols created by the aircraft and the aerosols created by the ships and created by humans, then you have even more of this soup that is going to increase the amount of refracted TSI and drop even lower. And we have seen numbers talk about the amount of energy created by CO2 as being 1.5, 1.6 watts of warming, but when you look at the math of what galactic cosmic rays will do with the amount of aerosols and other junk we got up there, you're talking as much as 6 to 8 watts of decrease in TSI. So if you add that all up and you speak to the coronal hole streams and how they can possibly drop the TSI, what are your thoughts to that, John? Could you speak to that? I know that's sort of a long-winded question. Tell me what you think.
Your question is actually all-encompassing of a lot of things that are going on with our sun. And let me step back and try to back into an answer for you. When the sun goes through its cycles, and right now it's at the peak and on the downslope of the 206-year cycle, that cycle basically produces a number of measurements, a number of parameters that I follow and others like me follow. Coronal activity, solar wind, cosmic rays, atmospheric nucleation from cosmic rays, cloud cover, aerosol counts. All of these things end up becoming part of the soup of measurements that we all look at to determine, is this consistent or not consistent with these solar cycles? Bottom line is they're all very consistent. And let me add one that you did mention, the Danish scientist Dr. Hans Fenmark, who has shown through his research for quite some time, many years, that increased cosmic ray count does end up nucleating cloud cover worldwide. And the more cosmic rays, the more clouds we have, the more clouds we have, the more reflecting of the incoming sunlight we see. And what does that mean? It means we get colder. The more clouds, the colder it gets. The more reflected sunlight that doesn't reach the surface of the Earth, the warmest. Obviously, that goes back off into space, reflected from cloud cover. So what we are seeing now, for example, are the largest, highest number of cosmic rays hitting our upper atmosphere than we have ever recorded since the satellite era began in 1979. This is striking. If you look at cosmic ray counts and compare them with the last 4 or 5 or 6 11-year solar cycles, there's a direct inverse relationship. When the sun is active and reaches the peak, then the cosmic ray count is very low. When the solar activity is low, cosmic ray count is very high. And the reason for that is the solar wind that's coming from the sun and the increased magnetic field of the sun tend to push out all of these cosmic rays that are coming into our solar system from the rest of the universe, the rest of the galaxy specifically. And as long as these cosmic rays are being kept out, then we have relatively low cloud cover. But now that the sun is weakening, the solar wind is weak, the magnetic field of the sun is weak. These cosmic rays are now coming in at a greater rate, the highest rate we've ever recorded. So this says, according to Dr. Svenmark's work and the work done at CERN, that yes, we should expect to see cloud cover grow, and we should expect to see a colder planet as a result. But again, that's very consistent with the 206-year cycle. That's exactly what we should be seeing right now, leading into the Eddy minimum over the next 20 years. And they are all symptomatic of what happens when we have a change in climate.
And our hypothesis on that is if you have the exact same amount of TSI and we have the exact same amount of galactic cosmic rays that we had during the Maunder minimum, that increased amount of particulate created by jets, created by ships, created by automobiles, and all the other pollutants and aerosols going into the sky. We believe that if that exact same circumstance were to happen today as happened then, it could be worse now because of all the additional particulates that are in our atmosphere. That is just food for the nucleation of particles to interact with as they travel through our atmosphere and create that cloud nucleation.
Well, you're certainly correct that any increase in nucleation aerosols leading to cloud formation would, again, reflect sunlight and make the Earth cooler. Let me add a comment to this. One thing we haven't mentioned is the impact on volcanic activity in climate change. About aerosols, that's where you get a great deal of periodic aerosol injection is from major volcanic activity. Go ahead, Jake.
Sorry, yeah, actually, that's kind of funny you mentioned that because I was getting ready to shift gears. Another part of the grand solar minimum that we really haven't touched base on, done a lot more focusing on the weather and climate and the crop situation, but there is another aspect to the grand solar minimum, and this is really covered in your latest book, Upheaval. But why do catastrophic earthquakes and volcanoes seem to come at the same time as these solar minimums?
Yeah, that's probably one of the great unanswered questions of our era. We deal with so many questions we read about in the newspapers every day about Russian collusion in the election and other absolutely worthless topics, where clearly one of the most important questions we should be asking is why do we get our worst earthquakes and our worst volcanic eruptions during these grand solar minimums, or what I call solar hibernations? Because that tells us what's going to happen in the future. What we do know from the research very clearly is that we do see the worst earthquakes and worst volcanic eruptions as the sun goes into these deep minimums, these hibernations. When the Earth gets cold, we see these catastrophic earthquakes and volcanic eruptions. The mechanism is still not understood, and there's a reason for that. In the last 8 years of the Obama administration, unless you were doing man-made global warming research, as a researcher, you didn't get any money to do that research. Everything had to be based on global warming and supporting the myth of global warming.
Wow.
Otherwise, your university, your science department did not get any government grants. And that's important because uh, my theory for climate change, the relational cycle theory, has proven to be far superior to the greenhouse gas theory in predicting climate variation. Whereas the global warming CO2 community relies on the greenhouse gas theory to produce global warming, solar activity and the RC theory rely on global cooling. And obviously, no one's going to fund global cooling research during the last 8 years of the
No,
Obama administration. Right
absolutely not.
now, we're seeing a lot of changes back to hard science, back to data, instead of politicized science, models that don't work, scare tactics by the environmental community to raise money and to push for political change for something that's not needed. Hopefully, we will see the Trump administration as it matures to start to turn the tide of bad science back to good science.
Speaking of that, let's talk a little bit about the history of earthquake activity in the United States over the history of these minimums. Let's talk about the earthquakes that went up through the middle part of the country, through the west coast to east coast, actually, and the history of those with the history of these minimums. Just discuss how throughout history, going back, as we see the correlation of these types of catastrophic earthquakes, I think the strongest one was a 9.0. That type of activity. Let's talk about the history of the earthquake versus solar minimum, or alongside the solar minimum, so people can realize we have a history of this type of earthquake activity in the United States alongside these grand solar minimums. Looking at how it was back then versus how it will be going into the future.
Well, fortunately, picking up from the last question, we now know that when we go into these solar minimums, we have these waves of catastrophic earthquakes and volcanic eruptions. That's what history has shown going back thousands of years. Uh, our most recent work, which actually was years of science put together in one book, which you mentioned, Upheaval. Let me see if I've got this handy. This book, which was published in December of 2016, documents very clearly this collateral damage from solar minimums and cold climates and earthquakes and volcanic activity. In this book, we go through in detail, show why California, Oregon, Washington, Alaska, the central United States, South Carolina, Puerto Rico, all of these areas are going to see catastrophic earthquakes as the sun cuts back on its energy output and goes into a solar minimum. That's what the science says. That's what history has shown repeatedly. And so we should start getting prepared for not only a new cold era, but our worst earthquakes and our worst volcanic eruptions that we've seen in over 2 centuries. And that's all documented in Upheaval.
Yeah, speaking of upheaval, thank you very much for the copy of that book. A great read so far for me, and I'm starting to understand a lot. This is all coming together for me. I'm having that aha moment myself right now during my research and everything. And I also wanted to mention, I didn't mention this in the beginning of our intro, but you hold a pretty high seat for prediction center at the earthquake and volcanoes. Could you expand a little bit about that for us?
I am the CEO of the International Earthquake and Volcano Prediction Center. Fundamentally, that's a global collaboration of seismologists who have, over the years, many decades in some cases, developed techniques for improving the science of earthquake prediction. These scientists, the world's best in their field, came to me in late 2011, and they asked for me to put together a company here in the United States to bring together all of the best scientists in the world in the field of earthquake prediction and seismology. So we did this. We formed the International Earthquake and Volcano Prediction Center, the IEVPC, in February of 2012. We've since gone through 3 test phases in the process of trying to develop a fully integrated chronological prediction system. And I'm very pleased to say we've had tremendous success in doing so. So thanks for asking. The IEVPC, we think, will reach a state of acceptance internationally that we're hoping for in the next few years. Sadly, during the Obama administration, we've had the U.S. Geological Service, the #1 authority on geology and seismology here in the U.S., pretty much put their thumb down on groups like ours or anyone else that wants to predict earthquakes. Sadly, for decades now, the establishment science in the U.S. government says that no one can predict earthquakes, even though we've shown that we clearly can, and others have.
Yes.
Sadly, the science establishment has put up barriers to groups like ours around the world who have shown that we can predict earthquakes.
Back to your book, Upheaval, what can be done to prepare for a catastrophic series of earthquakes predicted in your book, Upheaval?
Well, the good news about that is where my previous book, Dark Winter, talked a lot about the science of going into the new cold era. We didn't talk much about preparation. I had many people that came up to me and sent me emails and during presentations would ask how to prepare. So your question is appropriate. So what we did as a team of researchers, we actually put a lot of how to prepare for these catastrophic earthquakes in the book Upheaval. If you look at the book, it describes not only the threats that we actually will face and the probabilities of catastrophic earthquakes in California, the central U.S., and the New Madrid seismic zone, for example, but we actually say for individuals and families, for businesses, and for government entities, we give in each category a host of steps of preparation that one can go through. So the book, although it has a lot of great science in it, is really written for the average person on the street and is very much directed at how to prepare for these new catastrophic earthquakes that history shows are coming with this next climate change.
It is written for everyone to understand. You don't have to have a PhD or a master's to read this book.
Right.
John, you did a very excellent job in translating this information so the average person can get this information. I guess my last question I have, it's a 3-parter, and it goes along the roles of, can mankind really do anything about climate change, and speak about geoengineering, and finally the roles that volcanoes might play in a climate change.
Yes, mankind can affect the climate, but right now only on a very small scale. There have been lots of studies done by me and others with regard to sending large fleets of aircraft around the planet, dumping aluminum powder and barium sulfate powder and things of that type. But you're talking about many years, a great deal of money in the hundreds of billions of dollars just to get any meaningful change. Let me give you a for instance. In the 1991 volcanic eruption of Mount Pinatubo in the Philippines, it lowered global temperatures dramatically for almost 3 years. To do the same amount of global cooling, we would have to put up hundreds of aircraft at hundreds of billions of dollars cost to lower the temperature for 2 or 3 years. We simply cannot afford to do that. Most countries on the planet are heavily in debt. No one has that kind of money to spare. So I simply don't see the kind of geoengineering that you're talking about happening anytime soon because it's cost prohibitive. Furthermore, all you have to do is wait till the next major volcanic eruption and you're going to have your global cooling produced anyway. Furthermore, all you have to do is wait for the next climate change, which is now coming, and you won't need to do this geoengineering anyway. Geoengineering got its start, of course, as another scientific myth to try to cool off a planet that's going into hyper warming caused by mankind's industrial CO2. So it's a myth built upon another myth. It simply isn't going to happen. And it's a moot point anyway, since now that we're heading into the next solar minimum, the planet's going to get very cold. There's no need for geoengineering.
Yeah, and I'm glad you mentioned that because we come from a community where a lot of people believe the government sprays chemicals in our atmosphere on a daily basis. It was really important that you mentioned the cost because you're right, nobody has that kind of money to do a continuous spray. People think that the atmosphere is constantly sprayed with, chemicals to change the weather, and like you had stated, it would just simply cost way too much money to do such.
There's a very good example of how mankind can affect climate. There's several very good studies done on this, but they're all regional, they're all local. One of the best studies done, however, was after the 9/11 terrorist attack. During that period of days, we had no aircraft flying anywhere in the US. What we found out from that was that the aerosols being released by normal aircraft exhaust engines were in fact causing a warming effect. But it reached a static level. It reached a static level. So when the aircraft stopped flying, the particulate matter dropped because the aircraft exhausts weren't being produced. And we actually saw a cooling trend. But then when the aircraft got back up again, we saw, the level of aircraft aerosols back up, then things returned to normal. There was another study done in India which showed that industrial activity producing CO2 and other greenhouse gases did contribute to a cooling in a certain region near India. But again, it was localized. It was regional at best, certainly not global. The only way that we can show for sure that there's a global impact is when we have a major eruption of a volcano in the class of volcano explosivity index 6 or 7. Then we get global climate effects. But for mankind to produce it, again, hundreds of billions of dollars and hundreds of aircraft flying at the same time to equal only what we saw in the Mount Pinatubo eruption, giving us 2 or 3 years of cooling. We simply cannot affect the climate and in no way affect it to the degree and the scale that the sun does on a daily basis.
Right.
Hey, John, could you explain the importance of the double peak during this solar cycle and also the importance of the second peak being higher than the first peak?
Thank you very much. It's probably another question that we should be seeing in the mainstream media, but of course they don't want to talk about it. The reason they don't want to talk about it is because for any solar scientist who studies climate variation based on the sun, the peak of activity in this current 11-year solar cycle, number 24 it's called, solar cycle 24, is truly unique and truly indicative of how controlling the sun is. Basically, in every 11-year solar cycle, you have an up and down, the sun gets active and then inactive. At the very peak, you don't have a smooth peak. It's always a double peak, and then it drops off. into the next cycle. In solar cycle 14, the second of that double peak was the more powerful. And it was based on that I predicted that 2015 and 16 would see a spike in global temperatures because it produced a spike in solar activity. Whenever we look at long-term solar activity, I'm talking over hundreds of years, going back to when we first began looking at the sun's activity and right after the telescope was invented or made popular in 1610, we find out that when we have a solar cycle with a very active secondary peak at the top, when you get a small peak and then a larger peak before it drops off, that happens only just prior to a major cold era beginning. And that's why this last double peak at the top of the 11-year solar cycle is so important. It's the sun sending us a final message to get prepared for a new cold era.
Thank you very much, John. All right, the next thing I wanted to add on was with your predictions. I would like to know, have you reviewed Valentina Zarkova's work? If you have reviewed that, how do you think that influences your predictions as far as sunspot counts for cycle 25, cycle 26, and cycle 27? Could you share your thoughts on what you think about Valentina Zarkova's work?
Dr. Zarkova is at the University of Northumbria in the UK. She and her team came out about a year ago with a study based on the sun's magnetic field and how the magnetic field of the northern and southern hemisphere of the sun are at various times in phase and then at various times out of phase. And what she found out is that when they're out of phase, they cancel each other out to an extent. And during these periods of canceled magnetic field, we have our solar minimums, we have our solar hibernations, and the Earth gets very cold. This is very profound and great science. Dr. Zarkova and her team were roundly criticized by the BBC and other mainstream media here in the US for having come up with a very strong scientific theory that counters the man-made global warming theory. But she's absolutely right. If you look at cycle 25, 26, and 27, we believe they will be on the same scale as the Dalton minimum. Dr. Zarkova's research echoes that. Dr. Abdusamatov, the leading Russian theorist for this next cold epoch, says something similar. So the prediction for sunspots, to be specific in answering your question, are that the next two cycles, 25 and 26, will see no more than a 50 sunspot average at peak for both of those cycles. That will put us in the category of a Dalton minimum, which is the same level of decline in solar activity that I've been saying for the last 10 years. Dr. Abdusamatov, on the other hand, and some of his Russian colleagues believe that we'll be seeing not 50, but close to 0 sunspots, even at the peak of the 11-year solar cycles for 25 and 26, and definitely by 27. If you follow the Russian interpretation of the solar dynamic models that exist, they're saying we will be in a little ice age by solar cycle late 26 and early 27. Hopefully we aren't. I believe we'll be coming out and starting a warm up in cycle 27. I haven't given a specific estimate at this point for the number of sunspots, but hopefully it will be back up in the 60, 70, 80 range at peak and be moderately warm, but no way will it be warm like we're going through in the last few years.
Okay, and we follow a lot of work coming over from Russia, and we do agree with what the Russians are saying.
A lot of people do, yeah.
Yes, exactly. And that is the model that we're looking at. And that, with the increase of galactic cosmic rays that are coming in, I think our TSI is going to drop even greater than that, than the Dalton.
Here's my only concern with the Russian forecast. The Russian forecast is based on a Maunder minimum. So it's important to understand the Maunder minimum began, the Maunder minimum was at the very bottom of the Little Ice Age. The Little Ice Age started in 1350, and the Earth progressively got colder and colder and colder until the 1600s and 1700s, the very bottom of the Maunder minimum. And then it started to warm up again, and then it got up in the 1700s. In the late 1700s, it started to cool again and went into the Dalton minimum. But then it's been climbing for 200 years. So the Earth has been absorbing lots of radiant energy and other forms of energy from the sun for 200 years. That's one of the reasons I think we're not going to be as cold as the Maunder minimum. We've been through 200 years of heating, and it's going to take some time for that to dissipate. It's one of the reasons why I think everyone has been confused over why there's been effectively no growth, but no major change either one way or the other for almost 20 years now in global temperature. Even though we've seen instances of global cooling, and more so in the last 12 months, the fact is the Earth has been heating up for 200 years. It's going to take a lot of decline on the part of the sun to cool off this very hot blue marble revolving around the sun.
Indeed, indeed.
But you may be right. I mean, well, I will tell you this. By the third or fourth year of the start of solar cycle 25, and I'm talking specifically in years, we're looking at 2023 to 2026. In that period of time, we will know for sure whether we're going into the very difficult Dalton minimum or the far worst case, a Little Ice Age. We will know fairly soon how cold it's going to be. Actually, that question he gave in my answer is a very nice summary and a good endpoint for this discussion, because it says, okay, here's what we think is going to happen for the next 20 or 30 years. And it's important to understand that we will know, let's see, we're looking at the bottom of this next cycle at 2019 or 2020. We'll need 3 to 5 years, so 2023, 2025, we will know for sure how cold it will be.
Yeah, and you guys were talking about galactic cosmic rays and the cloud formation, and I can tell you it's very real. I can see it right now, and we live in the Buffalo, New York area, and we can feel it in the air. We can feel how these particles interact and almost form like a natural air conditioning in our atmosphere. But you could feel it. There's days up here in Buffalo where the temperature says 75 degrees, but the wind's blowing and your skin is cold to the touch. It's 75, 80 degrees outside.
When the sun is back on its energy output, there are real effects to that. Plant and animal life are the very first to recognize that that's changing. I have had numerous people in the agriculture industry tell me that crops are simply not growing like they used to, maturing as quickly, yielding as much as they used to.
Yeah. So, John, I have another question. I know we're getting ready to wrap it up. On the next 3 solar cycles, you're thinking they're going to be 14-year cycles based on the history versus 11-year cycle, or even something shorter than that. What are your thoughts?
I understand. We should see them longer than 11 for sure. But I'm not as much concerned with the duration as I am the depth of the drop in TSI and the increase in cold weather effects. If we use the 11-year cycle, you're looking at 30 years. If you use the 13 or 14-year extension from the smaller cycles, which we often see, then you're still looking at 26 to 34 years. still a long period of time to be cold, long period of time to have devastating earthquakes and volcanic eruptions. It's going to be a very challenging period for mankind.
Indeed, it will
Well,
be, John.
I really appreciate all the work you're doing in keeping the story of the Great Minimum alive. The Eddy minimum is going to really be a turning point for the civilization of the human species. The more we can get people like you to talk about it, the better prepared we will be.
That's it.
And I don't want people to go into this difficult era of catastrophic earthquakes, volcanic eruptions, and deep cold periods with food shortages on a totally negative basis. I want people not only to be prepared, I want them to thrive. I want them to do well. If you look at every single period in human history, there's been a group of people who did well because they adjusted, they adapted, and they got ready and prepared for what was coming.
That's
Well,
exactly
and
why we're here.
we have a guest next week. We've already had him on once, and the hope is that we get to talk to you again in the future. But this gentleman that we're having on again, his name is Ice Age Farmer, and he is growing himself right now. But he's doing things like the growth of moringa. I know you've probably heard David from Adapt 2030 talk about it. But this guy shares all kinds of useful information: aquaponics, growing. So that's we want to get as many people involved with this conversation. We want experts in sunspots like yourself and volcano and earthquake prediction. And then we got guys like Ice Age Farmer who really know what they're doing when it comes to growing. So that's the goal here at the Grand Solar Minimum channel. And with that, John, thank you very much for joining us tonight.
John.
I can't express enough how greatly we appreciate your work and value this time that we had with you tonight. That's going to do it for us tonight, folks.
Thanks, guys.
Thanks for joining us as well. We'll talk soon.
Bye. Thank you for tuning in to the Grand Solar Minimum channel. Today I would like to discuss 3 of the main solar cycles that we discuss on this channel. There are regular solar cycles, grand solar cycles, and super grand solar cycles. First off, let's explain a solar cycle. The poles of the sun's magnetic field change places each 11-year activity cycle. The north pole becomes the south magnetic pole and vice versa. Thus, the 11-year cycle of the sunspot frequency is actually half of a 22-year solar cycle in which the magnetic field reverses itself repeatedly. Actually, the length of the activity cycle is not exactly 11 years. That's just an average value. Sunspots are regions where the solar magnetic field is very strong. In visible light, sunspots appear darker than their surroundings because they're a few thousand degrees cooler than their surroundings. Near the minimum of a solar cycle, it is rare to see sunspots on the sun, and the spots that do appear are small and short-lived. During the solar maximum, there will be sunspots very visible on the sun almost all the time, and some of those spots will be very large and last several weeks. So we have this 11-year cycle of sunspot frequency. It goes back and forth from maximum to minimum as the magnetic field changes. So what is a grand solar minimum? Well, a grand solar minimum occurs when several of these solar cycles exhibit a lesser than average activity for decades or even centuries. Solar cycles will still occur within these grand minimum periods, but at a lower intensity than usual. There has been a lot of correlation with global and climate changes with grand solar minimums. We'll get into that on another video. So what is a super grand solar minimum? In Valentina Zarkova's recent paper, Oscillations of the Baseline of Solar Magnetic Field and Solar Irradiance on a Millennial Timescale, she describes a super grand cycle. Let's take a look at the chart in figure 2 in her paper. Breaking it down in the most basic way possible, looking at this chart, you will see all the solar cycles in a 20,000-year summary curve. There's grand cycles of 350 to 400 years of solar activity. There are also indications of super grand cycles marked by the vertical lines on the graph. These black lines, if you look at them very clearly, in each block between these black lines, you will see 5 grand solar minimums. So super grand solar minimums are 2,000-year blocks approximately of even lower solar activity. These solar cycles again are approximately 2,000 to 2,100 years. The minimum of the current super grand solar minimum started around the time right before the Maunder grand minimum. If you go back in history, you will see how prolonged and long that grand minimum was. There is a lot of confusion, and I wanted to make this video specifically to explain to people there are many different cycles, some that overlap, and it can get very confusing. I plan on doing more short videos like this to explain the more technical information in a very layman's way. Hopefully this clarifies the difference between regular solar cycles, grand solar cycles, and super grand cycles. Thank you for tuning into the Grand Solar Minimum channel. Please like and share.
Today we have a very special guest with us, Dr. Valentina Zarkova. She is a professor of mathematics at Northumbria University, also a PhD in astrophysics. A recent paper that she has had published in nature.com as of June 24th, 2019, Oscillations of the Baseline of Solar Magnetic Field and Solar Irradiance on a Millennial Timescale. Valentina, how are you today?
I'm doing very well, thank you.
Great to have you on. I know you and Mari have had several conversations dealing with this paper. And so today we thought we'd bring you on and once and for all kind of explain a bit about the paper. And there seems to be a little bit of confusion out there, not from this side. We are totally clear on what's going on here. So basically, if you wouldn't mind, I guess we could just start and talk a little bit about the process. You came out with a presentation in October. This was a long process, as is the peer-reviewed journals are. But if you could just kind of take us back to how things kind of started and got to where we are right now with the paper.
Yeah, first of all, can I tell you that I wasn't so busy with the paper, but with the exam board and marking, finishing, and doing evaluation of my modules. Only now I'm getting towards the paper because it will be reported next week on the National Astronomy meeting. So this is why we eventually prepared the press release, and hopefully it will be going out either tomorrow or Monday on our side and the Royal Astronomical Society side. So we're working on it, and so this is what I started doing. And of course, I was involved with this unexpected, because we didn't have press releases. I thought people wouldn't see yet the paper, but it turned out some people read the journal much more extensively. And so obviously I got involved in some interviews. Actually, it was radio from Manchester who got me on Tuesday even.
I heard that.
Guys.
I heard that. Very good interview there.
Yeah, it was a very good guy, actually. And he interviewed Akasofu. He knew the problem. So obviously it's not only us who understand the problem, there are many others. So definitely this is the happening. So it's nice to consolidate alike people. I really was pleased to speak to the person, I had to say.
So let's get right into it, I guess. First subject I wanted to talk to you about was the super grand solar minimum cycles. I think a lot of folks might have misinterpreted what exactly the definition of the super grand solar minimum. So if you could just kind of tell us about these super grand solar minimum cycles and how this came about.
Okay, so let me explain that the solar activity, this is something which is happening on the sun. And what we done in the previous paper, we detected these double dynamo waves which interfere and produce this grand minimum every 370, 400 years. So this is fine. This is what happened on the sun. On the way, while we're working on this, we managed to derive the formula for these waves. So this makes our life much easier, because now we can calculate this wave as long as we wish. And in the last half year, we calculated it backwards to 120,000 years. So, and when we did it, we discovered that when you look at the summary curve which describes solar activity on the sun, there are patterns which repeat every 5 grand cycles. So every 5 grand cycles we have first cycle slightly higher amplitude, narrower cycle. Second cycle amplitude lower, cycle wider. The third cycle has something also particular. And when you produce this for 20,000 years, you see how you can split them into particular parts, combining 5 cycles, which the shapes repeating each other. So this is the first visual view at this cycle, which really surprised us all. So we thought, oh, what is going on? So we get this 120,000 years of data. So we decided first to see what is this cycle. At that time, it was visual definition, about 2,000 cycle. Can we find anything on the sun? And we couldn't find anything on the sun. Sun works with 2 dynamo restlessly for billion years and nothing else. So I thought, where this nice pattern comes from? Because when you look at the paper on the, I think it is the figure 2, upper figure 2, the red curve, which shows you nice patterns with the 5 repetitions, and they look very, very similar. If you look at your screen, we put vertical lines to show how similar they are, so it's visually. But when you see them visually, of course, people would not believe you that you see the same pattern. They say you're making it up. You built specifically this curve to show us pattern. So this is why we started doing statistical analysis of the data. We started applying filter, trying to get this pattern 2,000 years. So we needed to run the filter about 1,000 years to suppress all other oscillations of the 11-year cycle, because the amplitude is biggest. So we wanted to suppress. When you run 1,000 year, it becomes very average magnetic field. And we also played with the 20,000 year filter. So you again suppress all the oscillations. And when you're playing with 20,000 year filter, we discovered this 40,000 year oscillation already seen in our curve between 6. It is figure 1 bottom, which shows you 40,000 years cycle, which is actually, it is the cycle, Milankovitch cycle, because of the Earth's obliquity.
Yes.
So the Earth's orbit is inclined towards the ecliptic. Now it's 23.5 degrees, but it varies 22 to 24.5. And we discovered that indeed we see in our curve this change of obliquity within 40,000 years. The period is, Milankovitch says, he calculated 41,000 years, and we see it in our curve. Suddenly this clicked that, obviously our curve has not only solar activity, but because we observe this activity from the Earth, Wilcox Solar Observatory is based on the Earth at Stanford. So obviously we cannot avoid orbital motion effect on this. So we said, what can we see? Maybe these 5 cycles repeating each other, maybe this will be another orbital effect. So this is what we played with the filter about 1,000, and we discovered this very clearly. The cycle of about 1,150 plus minus 95, so we say 2,000, 2,100 years, which came with very high accuracy. So really surprisingly, for all 120,000 years, we got this cycle oscillations, but the magnitude, of course, of these oscillations were by order or even 1.5 order of magnitude lower than oscillation of the summary curve of magnetic field during normal cycles, because it includes solar activity with the big numbers. But when we suppress these big numbers, we discover these oscillations, which is basically of the zero line of magnetic field. So like if you have cosine function, cosine goes from 0 to 1, and then from 0 to -1, and zero line is when y equals 0. In our case, this y equals 0 turned out to be also a little bit fluctuating curve. So it is not exactly straight line, it is like slightly waving.
Right.
So this is what we discovered, that this zero line like trembling, but it trembled in very organized order within period 2,000 years. So at that stage, we of course be very puzzled and started looking what people had, because people are very smart and they already probably look at something. They couldn't explain it properly, but they had intuitive perception they should be right.
Right.
And we found this solar inertial motion, which was very actively promoted by Karvatova from Czech Republic, from Ondřeje, in 80s. 80s, 90s, even 2005, she still published. Probably now she retired. Before that, in 70s, it was Fairbridge and other guys who we cited in the paper. They first calculated this solar motion. That it turned out that our sun, would they tell us the story about solar system, how it was formed, and the sun sitting in the focus of the ellipse and planets rotate around it in the same ecliptics. It is a nice story for children. In reality, it doesn't, everything doesn't look like it seems. Because first of all, the planets are rotating with some angular inclination to this ecliptic. So what is for us ecliptics, maybe not the same for Mars or some other small angles, 5-3 degrees and so on. Plus, what it makes, the large planets, so they somehow rotate, they made the sun so move around the very center of the solar system. So it turns out, because of this deviation of the orbits from the classic ellipses and so on, that large planets impose that the center of solar system is slightly offset from the center of the sun. So the sun is a little bit, can coincide, but can be up to 2 solar diameters away from the center. So basically it moves on the cycle about 2 solar diameters towards in different part orbits, basically rotates around this barycenter. And so do the planets. So they pretend they rotate around the sun, but what the planets do, they basically rotate around the barycenter as well. And this is what creates a little bit confusion.
Okay.
And it turned out that this is the only effect which can explain possibly this 2000 cycle, because Karvatova and then Palush, he was also working in Czech Republic. They calculated exactly profiles, plus the guys from Australia, whom I cited, and the Kornus calculation, it was their calculation, orbital motion. So it captures many minds. So basically they calculated that indeed the planets make the sun move, not simple in straight line. It just rotates in some like spiral rotation, like we shown in figure 4 in our paper. And because of this one, basically what sun does, if this orbit of the Earth is ecliptical and it should sit in the one of the focuses of the ellipse, the sun cannot sit there. It start moving either closer to apohelium or closer to perihelion. If it moves closer to apohelium, the Earth's orbit becomes more circular, which means that magnetic field become higher because the Earth moves slower in the apohelium and the spring and autumn equinoxes, and much faster during the perihelium. So this is why we have increased, slight increase. It's only, I don't know, even you can say 1% or 2%. But it's essential that we have slight increase of this magnetic field because of this motion. And then when it moves in some other periods, moves away from apohelium, close to perihelium, the orbit becomes much more ecliptical, which means that we have much smaller magnetic field because this sun mostly sitting in the focus of the ellipse, and because the main part of orbit of the Earth is far away from the sun, so the magnetic field is decreased. So this is basically was the, I think, eureka moment for us, because what they said, the said that this imposes the period about 2100, some say 2400 years, period of rotation of the solar inertial motion of the planets around the sun. We got only maximum 2100, but maybe if you include quadruple components, maybe we will expand it bigger. We don't know yet. At the moment, as you know, our summary curve is based on the dipole magnetic waves produced by solar dipole. So this was explanation. So basically what this paper says, everything which was said about double dynamo is correct, is happening on the sun, it's beyond our control, it's always happening, and we always have this grand minima every 370 years or 400 years, they will be happening. But on top of this, we can avoid, we can remove ourselves that we are sitting in the Earth which orbiting around the sun, and planets are orbiting around the sun, and they all telling the sun what it needs to do. And this is reflected on this fluctuation of the zero line. So these are two effects which add together, and nothing we can do about it. We need only to embrace both of them, unless we are planning to nuke large planets and remove them from the orbits.
Right.
This is it.
And you know, and the reason why I led off with that concern of the 2,000-year cycle, I think there's a lot of people that misinterpreted it. The 350 to 400 years, the grand cycles, there's 5 of them in these 2,000-year super grand solar minimum cycles. I think some people were actually confusing the term as if it was going to be a much more intense grand solar minimum, a much colder grand solar minimum. People took that word super and thought that it was being referred to the intensity of this particular grand solar minimum, not that it was measured on a 2,000-year time scale. So that's kind of the reason why I wanted to put that out there, to really clarify for people who may not
The word super is related to the length of this cycle, not to its amplitude, to this increase, because grand cycle obviously has much stronger waves, much stronger activity, because it is real activity, 11-year-old, we can't avoid it, while this 2000 will have tiny few percent of the amplitude of the grand cycle, but it is essential because the sun physically moves closer to us and further, it affects our temperature. This is essential why we brought it up.
To clarify for the viewers that had some confusion about whether or not we're going into a super grand minimum or a grand minimum, my explanation to them, and I'm hoping I'm reading your paper right, is that the super grand minimum, the bottom out of that was right before the Maunder minimum, and we are coming up out of that, and that is causing that temperature increase.
Yeah, it was a very drop during the Maunder minimum because it was coincidence. It was grand minimum at the same time, and it was super grand minimum. So orbital motion of the Earth and Sun coincided with the minimum in the solar interior by dynamo. So the two coincided. This is why this minimum was so extended and so intense. We will not have for next to 1,100 years, luckily, and maybe the next grand minimum will not coincide with the minimum of this super grand cycle. So we will see.
And Mari makes a excellent point there, because my next concern that I wanted to address is so many people are focused on that warming that we talk about in your paper, the 0.5 degrees Celsius every 100 years, and altogether maybe 2.5 to 3 degrees over the next 600 years. That's all natural. There's nothing in your paper
Absolutely. And done by Akasofu. He was the director of the Space Institute in Alaska, and he published paper 2010, and they crucified him. They couldn't find the reason why would the temperature increase, but he was right. it is increasing. He didn't know the reason, and I'm glad to be able to give him the reason. He retired, but he's still there. Maybe he would read it and he will understand. Yes, he was right. And the reason is because the sun moves physically closer to the Earth, makes our orbit more circular.
Right. It will also be a little bit further from the sun. Is that correct? How I read that in
What
the
is
northern
happening, again, if it is ellipse, so if it is ellipse, your sun is not in the center, but in the focus of the ellipse, one of the focus. So the focus which is closest distance of the orbit is perihelion, when we have winter in the north. And if the sun is closer to perihelion, or perihelion, in perihelion and even closer, it means that we will have colder winter, because basically we will have less, the sun will not be close enough, will be cold. But if the sun moves closer to apohelium, it moves closer to the center of the ellipse, not to the focus. It means that in the apohelium, the sun will be closer to us, and we will have much hotter summers in the north, while Australia, southern hemisphere, will have much hotter, warmer winters, because they will be closer to the sun in this July period.
Right.
Yeah, while when we move to the December, the sun is still there. It doesn't move so quickly. It needs 2,000 years for it to move. So the sun's still closer to apohelion, so which means that it is further from the nearest point. So in 21st of December, sun is further from the Earth when it would be when it is sitting in perihelion. So basically making the Earth's eccentricity nearly equal to zero, moving to the center, which makes our winters colder, because it is further from the Earth in the winter solstice.
And it's amazing to me that there are some people who actually are more concerned and focused about the warming over 600 years, when we've got to worry about what's getting ready to happen in the next 30 years. And nowhere in the paper, from where I read, does it say anything about warming temperatures in the next 3 decades. So we're looking at the grand solar. And by the way, when we had you on our program 2 years ago, I flat out asked you, are we heading into a grand solar minimum? You answered yes. Today, as we speak, this paper confirms indeed 2020 begins the grand solar minimum period. And so for me, I think what I'm gathering from this paper the most is that we are getting ready to enter in some challenging times. We are going to see colder winters. We're going to see shorter growth. We're witnessing these shorter growth seasons right now. And I keep hearing from people, it's only going to get worse, because this is only the tip of the iceberg, no pun intended. But this is only the beginning of these conditions that we're getting ready to embark for the next 30 years. So I applaud your work, because it's able to look at both sides of the natural cycles, the warming and the cooling. But anything in this paper, to me, I'm taking is a huge red flag and a warning that we have to adapt, and we have to get ready for some challenges here in the next several decades.
Yes, you're absolutely right. Moreover, what in this paper we wanted to say, the Earth is capable to absorb the increase of the temperature, another 253 Celsius, and doesn't disappear. It keeps rotating where it is. Everything on the Earth keep living, because it done in the previous 120,000 years, had 60 of those cycles, no ever human interaction, and it managed to survive. So this is the thing. It's not so dangerous to have increase of the temperature. If we cannot do anything, then we embrace it and we prepare for it. So this is what my one of the conclusions. So it is not that scary. I don't know if it is. I'm not discussing this global warming human induced, but what I'm saying that the nature has the mechanisms how to handle it, and it been handled because the solar system exists about 4.5 billion years, so we're still there. So it is obviously handling it okay. Of course, our first problem, most essential problem in the next 30 years will be this grand minimum, because indeed, as you correctly said, growing period is very damaged, very reduced. So obviously northern parts, northern latitude, there will be a shortage of some vegetables, fruits,
Sure.
some food for animals and so on, and it will be worsening with every year.
It's going to trickle down. Yep.
Yes, and this is why I don't know how it is in your part of the world, but I had heating yesterday in my house because
goodness.
it was very cold, and it is end of June. I never had it before in my life. It was pretty warm, but now it is not so warm. So obviously it is cooling off. So I don't know who, but what I was trying to say that despite this cooling off, there will be still increase of the temperature because the sun is moving closer to us during the summer. So we might have warmer summer in the next years because simply it become closer. What it says that we mostly dependent on the solar energy and the solar irradiance.
Right.
So it is the main source of our lives, and I'm doubt very much. I don't know. As I said, I will not be advocating the planetary science. People have enough said in the different conferences about CO2 and other, but definitely what we see from the point of view, the system, sun and earth, they worked out very good relationship, and they support each other and survive for billion years.
You know, I've heard several forecasts for the next upcoming solar cycle. There are people out there who actually have forecasted lower solar activity, but still admit that, or they believe that human activity has more to do with the climate. And I really don't want to get into that whole debate because that's right now it's kind of one of those things that it's almost like politics. You don't like talking about it, but I know my understanding is that CO2 does not affect temperatures, and I think that's one of the biggest misconceptions of our time when you talk about the scientific part of climate. I guess the hope is papers like this will help connect the dots for other people out there. And I think here lately, we've seen a lot more mainstream. I've noticed. I know Australia Sky News, they're starting to mention a little bit more about how CO2 is a trace gas. There's a few rumblings here in the States. We're starting to talk about it a little bit more. And I think when people like you, such as your wonderful brain has presented us this work, I think more people like you will be able to help society accept what's coming. And I guess what I'm trying to say is that it won't be so absurd to think, because so many years we've been taught that CO2 causes warming and human activity affects the climate, and that we're just going to burn up as a planet. And if we don't stop emissions, then in 12 years, then we're going to die, or whatever the claim might be. And again, I guess what I'm saying is my appreciation for your work and what you're trying to explain to folks. It has nothing to do about being a whistleblower. This is just you applying your mathematics to your research field, and this is what, and it works. I mean, the spoiler moment, the spoiler minimum. I mean, you've explained already that you believe, and I think a lot of people agree with you, that supernova was the reason why we experienced minimum conditions.
Yes, and it was only one cycle which went out, and actually for the same period, remember we put in the paper the observations of the temperature during spare minimum show it was a maximum, while it should be minimum. During the minimum of the activity, we know the temperature decreases because solar activity decreased. And so this is very straightforward relationship. It decreased not much, a few percent, but still it should be decreasing. While what they measured, it was increased. So it's another issue, but coincidence with many other grand minima, Wolf, Hammer, Maunder, and others, when you look backwards, even the curve which was produced by Solanke in some cases, in many cases we have very similar. When they put the proper background of the cosmic rays, they hit the same grand minima as we did. So obviously we're walking in the right direction, and they walking. Of course, they're affected by the background, which they don't know what was 2,000 years ago or 800. So this, I understand they have the problem. But the thing about this current paper, it is not only explains that these oscillations come from solar inertial motion, what it explains that increase of the temperature by itself is not a big deal for the Earth. It can increase by 2-3 degrees because it's already increased by 0.8 degrees from around the minimum. So, and another 2.5, it will be definitely 3.5 degrees by 2600. And because we had about 60 of these super grand cycles in the past 120,000 years, the Earth survived pretty nicely. We don't have any records of during the Roman Empire any cataclysm or other. We remember that during Roman Empire they grew grapes in Scotland, where it's cold and wet now. So at that time it was pretty warm. So it probably explained that no, you can adopt and it will be nice and warm. So what? It will be probably higher sea level, but after that everything will come back as it was before. So the Earth is stable but dynamic system. So not everything just set up on this same level. And I would be very surprised that the planets are so vulnerable that the tiny amount, which is not detectable even, according to these planetary people whom I read, Professor Salby from which is Imperial College, and some, it was a conference in Portugal, the people showing different examples, and they sent me the papers proving that it could not be increased. So I trust they're doing proper job. They simply cannot get enough audience to believe to them. But from the general common sense, I would be very worried that the Earth would be so vulnerable that this tiny amount, which we cannot even trace properly, suddenly would send the Earth to the, absolutely disaster. If it was so easier, it will be indeed, the Earth would disappear in the previous 4 billion years, but it didn't. And this tells you that something wrong in this conception. And if you look at the paper by the same Akasofu, figure 9, they show how the people from IPCC extrapolated the temperature increase, and they used the linear extrapolation of the curve, which basically is Doppler curve, has maximum. So you cannot do this interpolation this way, and this is why the increase was 3 degrees, and they start scaremongering and so on. So what I'm saying, that even if we accept, and we know now that the temperature will increase by 3 degrees by 2600, but nothing dramatic will happen because we had this before.
Yep.
We just need to do something else, and this will be fine. This is the point of this.
And that's what I love about this paper, the honesty of both sides of this. There's nothing, you're not trying to support an ice age agenda. You're not trying to do any of that. You're showing us where we could run into a lot colder. And I believe you said that the next minima, grand minima, the 2020 through 2025, is going to be similar temperatures around the Maunder minimum type.
Yeah.
So, I mean, again, 0.5 degrees in 100 years is not that much increase. And if we look at the data on all these charts, I mean, we've got people arguing about 30 years of information. And the minute we zoom out and look at the 100 years, the 1,000 years, and 2,000 years, then they get upset because that shows, the big picture shows us that we are on a steady, not
Yeah.
a skyrocket warming or diving
Absolutely.
cooling.
We are on steady fluctuations.
Yep.
Also, when I may return to this grand minimum, when we predicted it, when we said that the sun has steady waves coming again steadily in its interior, one at the bottom of Tucker line and one close to the surface, and only the interaction changes, so we see different sunspot numbers on the surface. This was a big problem for many people who did different dynamo simulations, because somehow they came up with the idea that the sun is stochastic. So it doesn't have strict rule. It just produces the waves, stochastically. Woke up, okay, today I'm in bad mood, let's produce some sunspot. And then after that I'll go to sleep, I will not produce. No, if this was the case, then if sun was stochastic, then it would be on its last legs to the explosion. Normally all celestial bodies, like human body, they like some steady process. So the human body, if the person had heartbeat with a tachycardia, which is stochastic, so this person is about to die within a short time if he doesn't have stem or something in the heart. The same is with the sun. So what our model explained, that there's no stochasticity. The sun works like hydrogen atom. It produces these waves on the regular basis. The only difference that these waves have slightly offset amplitude and slightly offset the frequencies. And because the waves are interfere with each other, so you have either constructive interference where amplitude increases during solar maxima, or you have destructive interference where waves suppress each other and amplitude comes to the zero. And this is what, because the waves are off phase, so they periodically, they run into each other every 3,700 years, they come into destructive interference. But it doesn't mean that something changed in the solar interior. Sun even probably doesn't know what is happening on its surface. It producing these regular waves, like hydrogen atom, producing this emission in the atom. They sit in this wave function, electron sitting on its orbit, and they never change. This is what basically was main outcome of the first paper, that we remove stochasticity. Of course, there are some elements stochasticity because something changing the properties of the media where these big loops propagate,
right,
which becomes later sunspot. And this is indeed needs to be investigated. But after we sorted out that the sun is steady producing these waves, it's much easier to live. We can be confident that it will survive another 5 billion years before it is predicted to explode as another supernova.
Mari, did you want to?
Very interesting. Actually, yeah, it's the grasping of these cycles for people who aren't well versed with the science behind it. You have your super grand minimum cycle, your grand minimum cycle. You stated that the super grand minimum bottomed out right before the Maunder minimum. We are going into a grand solar minimum that is you're forecasting to be at Maunder level conditions. How do you think the effect of not being in a super grand minimum do you think that'll make it easier? Looking back on history, all the troubles and woes, I mean, we still are facing some major issues, but is it possible to say that since we're not going to be in a super grand solar minimum that we won't be as troubled as people were in the 1600s, but we will have more so concerns with societal issues with food supply and that kind of stuff? Do it make sense?
I believe we will have, it's a good question. I believe we will have slightly less temperature decrease in the current modern grand minimum compared to Maunder. Because at the Maunder, we were at the bottom of everything, bottom super grand cycle. Temperature was 0.8 degrees lower, so everything was a little bit cooler. So with the upcoming grand minimum, we will have slightly higher temperature from which we start from. So definitely decrease of temperature because solar activity stopped.
Right.
Will be slightly less because we already have this gained extra increase, so we have something to lose, which will be easier for us. And furthermore, this grand minimum which upcoming will last only 3 cycles, while Maunder lasts for 6 cycles. So we have less time to struggle, which again very good for us, so we can cope easier and survive everything with the modern technologies, heating and food processing. The problem will be, of course, to provide the food, and probably standard usual resources, growing potato in Great Britain maybe will not be acceptable. You need to grow them further south. And what my talk with the Manchester guy actually raised the question. I said that I've been informed that African countries are preparing actually to grand minimum much better than Europe. Because why they're preparing much better? Because they had snow first time in 150 years since they become measured in the last year. And they were asking me, Al Jazeera, I had a chat with them. I said, it is. I said, yeah, this is coming and you will have more. So they realize it will be cold. But what they realize, there will be much warmer in Africa than up the north in all the northern countries. So they're preparing, African country preparing the agriculture. So they start feeding northern countries and make a huge profit from it. And the guy from radio said they also had information that Chinese people, they're very entrepreneurial, they buy in actually lands and properties in Africa because of it. So obviously people listening what we are saying, not necessarily Western governments, but those entrepreneurial people, they know their time will come and we have no choice to pay. If you want to have potato, broccoli, we need to ask African country to deliver it because it might not grow up, if not this cycle, but definitely the following cycle, 26 from 2030, this will be the worst period. This is when we will be probably begging Africa, Mexico, and others to provide the food. And at that time, I guess the wall in America will work against you because you will be begging Mexico.
And you bring up a good point because some of these other countries are more prepared for this type of event. And you hit the nail on the head. The Western government is not prepared. In fact, when you have lawmakers in our government that want to make rules that will make it more expensive for energy, a lot harder to be able to afford food, with just all the politics that's involved with this situation. I'm scared that our lawmakers will take the money that we are spending our taxes on, and where we could use it for infrastructure repairs or maybe indoor grow facilities or whatnot. I'm afraid that there will be lawmakers that will take our money and invest it in things that are supposed to be stopping this, but it won't work and it'll be a waste of money. I'd rather put a bunch of money into something that could benefit us in the next 20, 30 years instead of fighting a fake battle with a trace gas. So I worry about that here in the United States. And it's interesting to hear you talk about Africa, because when I first started doing this research, a person I was very close to actually was talking about Africa being a possibility for us to be getting food. So you're echoing the same thing that I've heard as well from a trusted source.
Yeah.
So it kind of just, gave me one of those, I remember hearing about this. So it's not unheard of for the idea of Mexico or Africa. And I guess that brings me to my next comment, which would be we need to get our acts together and try to find a way to work together, because countries like that, if we're going to have to depend on them for our food production, we really need to start playing a lot nicer with everybody.
Absolutely. We need to be nice to our southern neighbors,
Yep.
that's for sure.
Yep.
Because this is what Earth and Sun teaches the humankind. Be nice to each other, and don't break with your neighbors.
That's right.
Because you might come and beg into them for something.
So true. We hope that it doesn't come to that. We hope that we never have to worry about our neighbors knocking on the door because of how bad things could get. But you're right. We need to be prepared for that. And there's a lot of mentality out there that's, the strongest will survive. Well, that's true to a point, but we also have to unite and help each other. Like you said, the earth has gone through this many, many, many times. It's survived. Nothing cataclysmic happened. We as humans, we will find ways to modify and adapt and, move forward and progress as a species. But with what we have in the near future, we have to get serious, because that could turn into other problems than just weather issues. We can deal with famine, disease, economy issues. There's so many things that are riding on this, and it's important that we all get the information straight and work together.
Yeah, we need to embrace what we cannot change. We can change what we can, but we need to embrace what we cannot change and adapt to it. And this is the point what I was trying to make. Of course, I could leave it, unpublished and everything. And they were saying, reduce the temperature 1.5 Celsius. And then when it will be increasing, that we didn't reduce it and the earth will erupt or explode. What I'm saying, no, it will not explode. It will last very happily after, with increase up to 3 Celsius, because it had it before.
Right.
It will come in and will go. So this is actually puts back in perspective this scaremongering which comes from the panel saying that it will be too hot and everything. Right. They say it will be even hotter and nothing will happen. So basically, I'm very curious how they start playing it around, that the temperature will be increasing independently of the heating by humans.
Right.
So this is important point. It's not simple that I'm saying this, what I'm just delivering, that Earth survived this, and it had many, many hundreds of those before. So now they need to understand that, no, heating does exist. Indeed, we don't object it. But it comes not from the source what they're saying.
Right. That's the biggest part. It's natural, just like the cooling. It's natural.
Yes. It's natural.
And people need to understand, too, once we reach that 2.5 to 3 degree mark at 2600, that's when we'll also start to witness a decreasing of the magnetic field once again. So, again, we're cooling and we're warming, and we're cooling and we're warming. And I'm really glad we had a chance to talk today, because I think there was a lot of for some reason, there were some misunderstanding statements about this. I don't see how, but they're out there. And I think you've really done a great job so far of clarifying what we have in front of us in the next 30 years. Do you have time to answer a quick question about pole shifts? I know that's may not be something that you're well versed on, or maybe you are, but we have a question from one of our subscribers. And if you don't want to answer it, that's completely fine. We can edit this out completely. But he asked if the changes in the magnetic field of the sun can have an influence on the pole shift that's also happening. So they're wondering about the magnetic pole shift here on Earth. What's happening with our sun right now? Could that have an effect as well with our magnetic pole shift here?
Possibly, I don't know. I never investigated this problem, but I can, the thinking aloud would to say, when the solar magnetic field is decreased during the grand minimum, so this is the essential effect for the whole solar system. We have the shield, solar magnetic field, which protects us from cosmic rays, from anything. Then this magnetic field will decrease for the next 33 years. Obviously, we will have huge invasion of cosmic rays coming from anywhere because nothing protects. But it also shows the magnetic field in the planets, which was previously suppressed by the magnetic field of the sun. This suppression will be gone. So what the planets will do with this, we don't know. We will watch it in the next 30 years. I'm very curious to see what is going on, what will be happening. But I'm sure it has to be something different than it was before when magnetic field was strong.
Right.
So this is the key point.
And then that has a domino effect on all other Earth systems, whether it's volcanoes, ocean oscillations, the jet stream, everything. It's such, I think that's the hardest thing for us reporting news on the Grand Solar Minimum channel is it's such a broad area to cover. There's so many different puzzles to put together, pieces of the puzzle to put together to understand what's going on with our climate, and everything sort of is interlinked together. So for us to actually truly know 100% what's going on, you would need a whole team of people with their different specialties. You have like Svensmark with this cloud project. There's groups on like SPACEWEATHER.com, the Earth Sky, that does
Dr. Tony Phillips
does cosmic ray.
Yes, I will send you the links to this paper for this conference, which was in Portugal, which planetary people came together and spoke about temperature, carbon, and so on. But probably most relevant to understand what is the effect done by the planet, El Nino, and different parts. Knowing what the sun is doing, you can discuss with them how the Earth responding what the sun is doing. So you can discuss with this. And then of course, the talk by Maurice Selby, who explained that there was another guy also in Canada who tells that carbon dioxide, the quantity of carbon dioxide is not detectable. The quantity produced by human is so little that it is not detectable on the background of the general quantity. And carbon dioxide is not all bad because all our trees live on the carbon dioxide. So the more we breathe, the more trees will be growing. Put more trees, it will be perfect.
And that's proven. NASA's shown us maps and satellite imagery that the Earth is greener.
Yeah, NASA is big on that this year and last year about how CO2 is the main cause CO2 is doing right now is greening our planet. You brought up the atmosphere and how small. On Sky News, they did a demonstration. This lady, they poured a bag of rice into a bowl, and the news commentator grabbed just 1 grain of rice and put it on the desk and said that's how much CO2 that Australians are putting in the atmosphere. The whole bowl of rice was the atmosphere, and that one little grain of rice was exactly the emissions. So when I hear people say that human activity has more to do with our climate, I would have to say that that's a little bit false, and I understand that there's people who learned a certain way, but it's just hard for me to look at them as a scientist anymore when they want to try to lie to people and tell them. Yeah, so honestly...
You look at the same happening on Mars. The same, we have polar caps on the Mars are melting at the same time like our Arctic is melting.
Right.
And who is melting them?
Who's driving the SUVs over there?
Yeah.
Or it's the Mars Jupiter rover.
It has typhoons now. It never had before. It means that its atmosphere is heating as well in Jupiter. Look at this. When you look at other planets, you immediately recognize that we are not capable of doing this. It has to be someone bigger than us. And the only person or subject bigger than us is sun. Nobody else can do. And this is why we cannot take everything that humankind does. Yes, probably pollution with the bad materials is not good. Maybe we need to reduce pollution because people growing up having cancer, having different diseases, this would be nice to make it cleaner. I don't mind. This is good thing. But to assign that the whole humankind and all our industries and all our heating producing this CO2 and planet is literally on the verge of to explode in the next couple of decades, this is a strong exaggeration. I'm just appalled.
You echo exactly what we believe here at the Grand Solar Minute. We agree that we could do a better job at making cleaner air to breathe, cleaner drinking water. We do believe that we do have influences on that. But when it comes to climate, when the information is just all wrong when it comes to telling people that it's your car that's causing global warming or sea rise or anything like that. Mara, did you have anything else that you would like to ask Dr. Zarkova before we wrap it up?
I asked people on Twitter if they had any questions, so would you mind if I asked you a few of their questions?
Yeah, please.
Okay. When I asked people on Twitter what kind of questions do you have for Valentina, a lot of people asked about climactic stuff, like you're a climatologist, and people don't understand. You don't have that kind of meteorological, I can't say that word, meteorological training on that. You are studying the most important aspect of these calculations that everyone's trying to puzzle piece together, and that is the sun. That's what you are providing answers to in this big puzzle of different pieces that everyone's trying to assemble. So, you know, it is what it is.
I came to climatology absolutely randomly. I was investigating the sun. We have a European project where we done nice automated pattern recognition, a lot of nice data extracted from digital images. So what we done, I was leading the group which is doing this in the digital era. You're trying to bring the proper methods and computers into all the science. So you're not drawing like people before sunspots and counting by hands. I said, okay, we passed the era of drawing. Let's do this computer. So we produced terrific solar feature catalogs and produced the sunspot for the cycle 23. And this is how I got into this subject. So we got these catalogs and we started thinking, okay, we can give it to other people to analyze them, or we can analyze them ourselves. So this is how I started learning what people did before, because I am actually a plasma physicist, theoretical physicist.
Right.
And I'm mostly better, I do high energy particles. I have papers in Nature for discovering sun quakes, or recently with my PhD students about H-alpha emission. This is why I know hydrogen atom, how it works. So this is my main specialty. But to get into the solar activity, it was as like tail from this big European project, which I didn't want to leave to someone just to pick up flavor of. And this is how we got into it. Even when we done the first paper, I did not realize what effect it will have on the whole status of the climate change, because I didn't realize that these people from IPCC start attacking me personally, like I'm trying to do something with their science. I said, look, I don't do your science, this solar physics. But somehow it turned out they're strongly interrelated, so they dragged me in. And this when I started since then, looking in all this other research in planetary stuff and others, people started sending me their research, sending me the link. So last 4 years was a huge learning curve for me. So I'm getting into the climatology slowly and not necessarily willingly, but I had no choice, because this is what I discovered, that I can tell people that increase of the temperature by itself is not a big deal. The Earth had it before.
Yes.
And it is still here. So we need to find something else for these guys. And this what up to them to find for time being.
I'm excited to see people take your paper and do their own research in their own specialties based on the data that you have, because I think once they apply your calculations with a new perspective, we're going to see some really interesting papers that reference yours from this. It's huge.
I would suggest some people should use the magnetic field data from other observatories. I simply don't, they ask, why don't you do this? I physically don't have time. I teach different modules.
Right.
I have projects funded by US Air Force to investigate high energy particles and magnetic connection in them. And we are on this second year of this project, and I work with my postdoc, and I have PhD students. So basically, I'm really tied up, and I have family, of course, my granddaughter, son, and all family. So basically, my time is very limited. So
Sounds
with
like
this limited time, we squeeze free time, not paid whatsoever, apart from donations, and do this research out of curiosity.
Wow.
But that's how we are, though. I mean, I relate to that. It's so time consuming.
Pushing down, nailing that you haven't done. I become, the more you nail, the law, the more you push, the more is resistance. So this is what I'm working straight on the physics law.
Wow.
I can't imagine how busy she is. We really appreciate the time that you have given us with this interview. I'm excited to be able to help you with your website. We're working on that. I've told people about that. So, we're hashing out the technical aspects of that. I'm excited that you are willing to take this time that you're not getting paid for or anything, just to help educate people and have people get a grasp on to what is going on. So I'm excited for your website, and I really would like to encourage our viewers to, if you can donate to Valentina, please do. And I'll put the links to everything on the website in the description. She deserves it. Like,
absolutely.
There's so many channels asking for this and that. There's people with fundraisers everywhere. Let's pool the money to people who make a difference, like Valentina, because I really respect your work.
Full time for me, not when I find the time. Then this person could do, like my postdoc. He works his paid salary. So even if I speak here, he's still doing his talk. He has also talk at NAM and everything. He needs to do it, and he needs to work on his CV to get the job. So this is working. But my part in this, I need to find my spare time. I need to finish all the gardening, all the everything, and squeeze the time and start doing it. So you imagine this is only out of curiosity, and only because I feel it is important to explain those kids, not even adults, that they were brainwashed to go on this strike because of the global warming. Unless they're planning to, they better go to school and learn astronomy and mathematics and learn that the temperature increase comes from the large planets. So doesn't matter how long they will sit on this strike, the planets will not move any inch differently. They still will be moving as they should.
Well, it's almost criminal what they're doing, using children for their agenda. They've pushed it to a whole nother level of just disgust in my book.
I don't call it criminal. It is like religion. So they believe in it.
Cult-like.
The religion. And any arguments doesn't reach to them because they believe in it. But what I'm saying, we might not be able to change the minds of all the people, but the young people, they will live through grand minimum, they will live through increase of the temperature, and some of them, the descendant will live to this when the temperature increases strongly, and then they will see it's doable, we can survive it.
But they
What do we
have
think
to
about?
they have to be paying attention. And
Yes.
that's the big thing that we're trying to get people to do
Awareness.
is just to follow it, as complex of an issue it is, pay attention, because there is a huge need for our farmers and people to make these changes to be able to adapt and move into it. And right now,
Exactly.
our farms are underwater. And it's going to be sort of scary over the next few years to see how they adjust.
Yep.
So
Some might not even be able to continue anymore as well. So, well, listen, Valentina, it's been a pleasure talking to you. We really appreciate you taking the time with us, answering some of our questions. I think this is going to help a lot of people understand what's going on right now. We do appreciate your time and for you coming on and speaking with us.
Good luck and keep studying.
Absolutely. You're the best teacher we
life
have.
is beautiful, but it is complex, and don't be afraid of complexity.
That's
It
good
is
advice.
easier to put it, step by step, and put all the complexity into components, and it will become very straightforward. Okay?
Great. Very good advice. All right. Thank you
Wonderful.
once again, Dr. Valentina Zarkova. Thank you.
thank you.
Bye-bye.
Bye.
All right. We appreciate everybody tuning in today. We hope everyone has a great weekend. We'll be back tomorrow around 4 p.m. for a grand solar minimum update. Until then, guys, stay safe out there. We'll talk soon.